Hi guys, in this video I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing polar curves or polar equations. So this is a very important part of AP Calculus BC, and yeah, there are many formulas which you must need to know. So the first formula is cosine theta is equal to x over r, or this can be written as x is equal to r cosine theta. So in polar curves, so you know how in the regular Cartesian plane is x comma y, but in polar curves it's r comma theta. And then the next formula is sine is equal to y over r. This can be written as y equals r sine theta. Another formula we should know is tan theta is y over x, because it's basically sine theta over cos theta and r's get cancelled. And then x squared plus y squared is equal to r squared. And yeah, and these can be written in like different forms, which can help us understand. For example, this is used in many ways, such as theta is equal to tan inverse y over x. And then this is also written as r is equal to root of x squared plus y squared. So these are the important formulas which you must know. There still are some other, but I'll be discussing them in future videos. So let's look at some questions. So they've given us r is equal to 2 sine t theta. They've asked us to find the rate of change of x with respect to, so WRT, with respect to theta. So there we have to find the rate of change of x. So what we know is x is equal to r cosine theta, and we know that r is 2 sine 3 theta. So then r cosine theta would be this times cosine theta. And now we know that this is our value for x in terms of theta. And now all we do is, for rate of change, we find dx over d theta. So we differentiate this. So what we can write it as now is 2 into sine 3 theta times, so u into v dash using product rule, times negative sine theta plus v, which is cosine theta, times u dash, which is 3 cosine 3 theta. And now we know what we can do is we can write this as 2 into negative sine theta sine 3 theta plus 3 cosine theta cosine 3 theta. And now finally our last step would be to just multiply out the bracket. So we get negative 2 sine theta sine 3 theta plus 6 cosine theta cosine 3 theta. So this is our rate of change of x with respect to theta. So now what we can do is we can solve part B. So part B says, so this is part B, find the rate of change of y with respect to theta. So it's basically the same thing what we did, but we'll use a different formula because y is r sine theta. Then this is equal to 2 sine 3 theta times sine theta. I'll just write it as a dot instead of an x. So 2 sine 3 theta times sine theta. Now what we do is we derive dy, or we derive y with respect to theta. That gives us 2 times cosine theta sine 3 theta plus 3 sine theta cos 3 theta. This can be written as 2 cosine theta sine. We're just expanding the bracket right now by multiplying all the terms by 2. So yeah, this is our answer for dy over d theta, and this is the rate of change of y with respect to theta. So now let's look at one more question. So they have given us a polar curve r is equal to 10 theta over theta squared plus 1 for theta is greater than or equal to 0. What is the instantaneous rate of change of r with respect to theta? And they have given us, we have to find this when theta is equal to 2. So what we do is, we have to find the rate of change of r with respect to theta. So we basically just have to derive dr over d theta. We can use quotient rule, so that would give us v into u dash, so theta squared plus 1 into u dash, which is 10, minus u into v dash, which is 10 theta times 2 theta, over v squared. So we just square the denominator. So like both terms in the denominator. So now we have to find out this value when theta is equal to 2. So what we do is we just plug in 2 into dr over d theta. That gives us 50 minus 20 into 4, which is 80, over 5 squared. So 4 into 5. 5 into 10 is 50. 20 times 4 is 80. Then 4 plus 1 is 5. So this gives us negative 30 over 25. Can be simplified to negative 6 over 5. So this is our value for the rate of change of r with respect to theta when theta is equal to 2. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I discussed polar equations and I gave an introduction of some of the formulas and discussed a few questions. Thank you, and please consider liking and subscribing.